Hello kids, I'm back with section 2.2 of Algebra 2, which is adding and subtracting rationals. But first, what do you call a scuba diver who is afraid of the water? Well, you call him the chicken of the sea. So let's go ahead. We're talking about adding and subtracting rationals. There's not a whole lot of difference in adding and subtracting rational numbers than there is from adding and subtracting fractions. You've had a lot of practice with fractions beginning in 5th grade, then you had 6th and 7th grade math, some of you had pre-algebra. So this should be pretty much a total review to you, as I talked about in class again on this past Friday. I'm not going to belabor these bits of material that are pretty much just review to you. You have other classes going on. This is material that's pretty much prerequisite for this course. They review it because what happens frequently is kids turn their minds off, parents let their kids turn their minds off during their summer and they forget everything they learned for the past 6 months. So it takes 3 months to catch up to what they'd already learned, and you guys are a great class. I know it's not going to be taking us that long. But I will go through and say that we have something, and I said this in class on Friday, you may already have this, fundamental principle of fractions. Fundamental principle, see I try to skip syllables when I'm writing principle. It's principle, P-L-E, not P-A-L, principle of fractions. Fundamental means it's very basic, very important, very foundational to what is going on. We say that if A is an integer, and B and 0 are non-zero integers, and B and C, I think I said in B and 0, and B and C are non-zero integers, they're different from 0, then this statement that I'm about to write is true. Then AB really doesn't do me any good just to smear this board. Let me try erasing that. AC over BC is the same as A over B. So what are we doing? This says all of these have to be integers, but specifically B and C have to be non-zero integers. So what are non-zero integers? Think back to when we're classifying numbers. We said natural numbers are the counting numbers, 1, 2, 3, 4, 5. Whole numbers include 0. Integers add the negative numbers to this. So if we have to have a non-zero integer, it's sort of a combination of the natural numbers and the real numbers. Actually, what it is, it's the whole set of integers except for 0. And they pull that 0 out of the mix because we learned that you cannot divide by 0. What this tells us is that if you have a numerator and a denominator, and it's written as a product of factors, if you have the same factor in the numerator as you do in the denominator, and if this is confusing you that I wrote this in different reverse order, let me say I have 5 times 2 over 5 times 7. How about over 7 times 2? We have 2 integer factors, 2 non-zero integer factors. One of them is the same factor in the numerator and the denominator. Those cancel out, and that's what it's this fundamental principle of fractions that allows us to cancel common terms or to reduce by the greatest common factor. This fundamental principle of fractions is very, very important because it's also going to expand to include canceling out like algebraic factors, right there. 4x divided by 3x. The x's cancel because those are also common factors. So we have this fundamental principle of fractions on page 52, and then they just go through and very quickly review adding fractions. So just a little bit more review. If you have 2 sevenths plus 1 seventh, how are you going to deal with that? Well, remember way back that when you're adding or subtracting fractions, the denominators have to be the same. If the denominators are the same, you just add the numerators. So you end up with a solution of 3 sevenths. Doesn't matter if you're adding or subtracting. If the denominators are the same, you either add the numerators or you subtract the numerators. We have 2 sevenths minus 1 seventh becomes 2 minus 1 over 7, which is 1 seventh. Very, very easy to add and subtract fractions. You don't have to reduce to, see what I want to do, you don't have to convert this problem here into an improper fraction. Notice what I did, I've changed this first problem, 2 sevenths plus 6 sevenths. Because the denominator is the same, we add the numerators, we have 8 sevenths. That's the answer. 2 plus 6 is 8. You do not convert that into 1 1/7. Just leave this as an improper fraction. We talked about, we talked about the, my knee the wrong way. Example 2, we talked about what do you do when you're trying to add 2 fractions together where the denominators are different. You have to have a common denominator. And the way that you find the common denominator is a common denominator is the least common multiple of the 2 denominators. They don't use this notation in your book, but I'm going to introduce that to you. You see least common multiple, greatest common factor of numbers that are a series of numbers and contained in parentheses. That just means, what is the least common multiple of 4 and 3? What do? Well, of course, first you prime factor 4, and then you prime factor 3. Those are really hard to factor, aren't they? In order to find the least common multiple, then, of 4 and 3, you take each specific prime factor the greatest number of times it appears in any one of these 2 individual factors. So you find out that your least common multiple is 12. You have to rewrite 3/4 as a fraction over 12. You have to write 2/3 as a fraction. 2/3 as a fraction over 12. What I did here, 2 times 2 is 4. Our least common multiple is 4 times 3. We already have the factor of 4 from our least common multiple. When we add a 3 in the denominator here, 4 times 3 is 12. Similarly, with 2/3, our least common, we have to have in the denominator our least common multiple. We already have the 3, so we have the factor 2 squared, factor of 4 left. So we multiply by 4 over 4, because when you multiply by something equal to 1, you don't change the value of the number. You change the appearance of it, but you don't change the value of it. Over here we multiply 3/4 by 3/3. Because what you're doing is you're multiplying by an expression that's equal to 1. You're not changing the value of this expression, but you are changing its appearance. Because 9/12 is the same as 3/4, it just looks different. 8/12 is the same as 2/3. Let me just take this here real quick. This is a pizza. So they asked the blonde, do you want me to cut your pizza into 4 pieces or 12 pieces? She said, oh, just cut it into 4 pieces. I'm not hungry enough to eat 12 pieces. Well, here it's cut into 4 pieces, and she says, I'm only going to eat 2 pieces. So I can't eat 6. I want to only eat 2 pieces. Okay. So she's going to eat this much of the pizza. Well, is there any difference in 2 pieces and 6 pieces? No, because if the guy had cut her pizza into 12 pieces, she would have eaten 6 pieces of pizza. But it's still the same as just that original half. So 3/4, 3 pieces out of the 4 original pieces of pizza, that's the same as 9 pieces out of 12. So those are equivalent fractions. Their form is different, but they represent the same amount. So when you add 3/4 plus 2/3 together, you have 17/12. That's your answer. There are no common factors in the numerator and denominator. You do not need to convert this into a mixed number. For the next week or 2, I won't mark you wrong, but why do the extra work? I don't want it to be converted into a mixed number. I want you to leave your rational number answers as rational number reduced to lowest terms. Do not convert them into mixed numbers. Okay? So then, you have the same thing. If you're going to subtract, you just create a common denominator and subtract. If you have a negative number, negative 17/32 is the solution to example number 4. That's what your answer is. Having a hard time turning my page here. See if I can get it to turn. Adding and subtracting rationals. If you'll look at your book, I want you to look at the top of page 54. It's where this has come from. I'm not going to take the time to write it down on the board. You're not going to want to listen to me read it to you. Copy it. If you're allowed to write in your book, highlight this. If you're not allowed to write in your book, change this into your own words. Condense it, make it smaller, and write yourself a note that says, this is what I have to do to add or subtract rational numbers. This is how I use the least common multiple to find common denominators so that I can simplify rational numbers, which what you've known as fractions. It says, do you remember how to add and subtract rationals in decimal form? I know you do because this was part of your pre-class assessment. It says add 2.39 and 14.682. What do you do to add rationals that are in decimal form? You have to make sure that you line up the decimal places, don't you? We have a differing number of decimal places, 2 and 3. Sometimes it'll help you to put a 0 in as a placeholder. 27071, hopefully. 17.072. When you're adding and subtracting decimal numbers, you make sure that you line up the decimal point. that's the end. Section 2.2, adding and subtracting rational numbers.